So the AI boom, it's literally everywhere, right? From the chatbots we talk to the art generators that create stunning images. But how does it actually work? In this explainer, we're going to peel back the layers on the key tech that taught AI how to understand our world. Let's dive right in. You've almost certainly used an AI already today, maybe without even realizing it. But have you ever just stopped and wondered, how does it go from a few words you type to a whole paragraph that makes perfect sense? That's the big question we're tackling, and it all starts with the foundation of modern AI. All right, so our journey has to begin with something called deep learning. This was the breakthrough that really set the stage for everything that followed. It's all about teaching machines to learn in layers, which you'll see is surprisingly similar to how we humans make sense of things. So, what on earth does hierarchical representations actually mean? It sounds super technical, right? But think of it this way. Instead of seeing a bunch of data as just one flat thing, deep learning models use many, many layers to build up their understanding. Each layer adds a new level of complexity. And this is so powerful because it's efficient. It's way easier to learn simple stuff first and then combine it, instead of trying to understand the whole complicated picture all at once. This process really does mirror how we learn. Like, as you can see here, the very first layer might just spot simple patterns, things like edges or lines or colors. The next layer up then combines those into basic shapes, like circles and squares. And then a layer above that might realize those shapes are a car's wheel, until finally it understands the entire scene. It's like climbing a ladder of comprehension, one rung at a time. And here is the absolute game changer. Before deep learning, engineers had to painstakingly, manually program every little feature. Look for this specific curve or identify this particular texture. Deep learning just figures all of that out on its own. It learns directly from these massive data sets, which is exactly why it was able to scale so incredibly well. Deep learning was powerful, for sure, but it had its limits, especially when it came to understanding language. Then, back in 2017, a new architecture came along that didn't just improve things, it completely changed the entire game. Welcome to the transformer revolution. Before transformers, AI models had to process text one word at a time, sequentially. As the slide says, it's like trying to understand a whole story by reading it through a tiny straw. You'd get the words, but you'd completely miss the bigger picture. Well, transformers shattered that limitation. They process all the words in a sentence at the exact same time, giving them a complete holistic view of the context right from the get-go. So how do they do that? How do they see everything at once? They do it with this absolutely brilliant mechanism called self-attention. This is the secret sauce. It allows every single word to look at all the other words in the sentence and figure out which ones are the most important for its own meaning. It's all about understanding relationships. This new parallel approach unlocked two game-changing benefits. The first one, as you see here, is just an incredible leap in speed and scale. By processing everything at once, we could suddenly train models on these gigantic data sets way, way faster than ever before. And I'm not talking about a small improvement. This is the key that unlocked everything. Without it, training a model like GPT on trillions of words would be practically impossible. It's what made today's massive AI models even achievable. And the second benefit? This is what makes these massive models actually feel smart. It's the ability to understand what's called long-range dependencies. This is just a fancy way of saying it can connect a word in the very last paragraph of a document all the way back to an idea that was mentioned on page 1. It's what lets an AI hold a consistent train of thought, remember details, and produce text that feels genuinely coherent, solving a huge problem that made older models feel kind of forgetful and robotic. Okay, I know that might still feel a little abstract, so let's make it really concrete. How does self-attention actually help an AI understand all the little nuances of human language? This quote really gets right to the heart of it. Our language is just full of words that can mean multiple things, right? And the only way to know the correct meaning is to look at the words surrounding it, the context. Okay, let's look at the sentence. When the model sees the word bank, its self-attention mechanism just lights up. It scans all the other words and gives a huge amount of weight or attention to the word river. It knows that river and bank are super strongly connected, so it concludes, aha, bank here means the side of a river. Now, check this out. Same exact word, bank, but a totally different meaning. This time, the attention mechanism latches onto the word money. It instantly sees that connection and correctly figures out that bank must mean a financial institution. This shows perfectly how transformers get context. It's not magic, it's just really clever math and relationships. And get this incredibly powerful idea isn't just for text anymore. In Vision AI, a picture is broken down into little patches, and attention is used to understand how all those patches relate to each other to form a whole image. For speech, it aligns spoken audio with written words. This one innovation is now the engine driving almost every kind of generative AI we see today. So let's tie all this together. We've gone from a system that learns in simple layers to this powerful new architecture that can see the whole picture at once. What does that all mean for the state of AI right now? Here's the bottom line. The transformer isn't just another cool tool. It has become the absolute fundamental building block of modern AI. The whole strategy now is to pre-train a massive transformer on a huge chunk of the internet, and then you fine-tune that incredibly powerful base model for specific jobs, whether it's answering questions, writing computer code, or making art. I mean, this architecture has just blown the doors off what we thought was possible even a decade ago. It is the solid foundation that pretty much all modern AI is built on. Which leaves us with one final and pretty exciting question to think about. Now that we have this incredible foundation, what are we going to build on top of it next?